What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, I'm going to show you how to use the distributive property with variables. Okay, so I previously did a video years ago talking about the basic rules, numerical rules, or whatever you want to call them, but there's one on the distributive property. Actually, it's on the properties of equality. That's the video series where I broke down the distributive property, the commutative property, the associative property, but I kept them very, very simple. And it dawned on me today that I need to go ahead and do these videos again so students can see how to use them with variables. So let's get right into some examples. Now, I have several examples for this one that I want to go over, and so let's get right into it. Example 1. We have -6 times the quantity A plus 8. Okay? Now, what happens is with the distributive property, remember the distributive property entails two operations. One of them will be multiplication, hence we have this quantity in parentheses, so we're multiplying -6 times this quantity. But we need to distribute this -6 across the A plus 8. So the first operation would be multiplication, and in this case, the second one would be addition. So I'm going to take this -6 and distribute it to both of those. So what I end up with is -6 times A, we can just put it right there, plus -6 times 8. Okay? So -6 times A is just -6A. Now the plus -6 times 8 is plus -48. Okay? You can leave it like this and that's fine, but I like to make mine look like this. -6A minus 48. Remember, subtraction is nothing but adding the opposite of a number. So either one of these versions work as a solution. But if you look at my work, typically I'll write it like this. Okay? That's example number 1. Example 2. All right, example 2, we're going to do another one. We're going to say 4 times the quantity of 3 plus 9x. All right, same thing. We need to distribute the 4 to every in parentheses. Okay, so 4 times 3, so 4 times 3 plus 4 times 9x. Remember, this is an expression, so we cannot figure out what the value of that variable is. Okay, so we're just simply going to 4 times 3 equals 12, plus 4 times 9 is 36, and we keep the x, and that is it. There's nothing more we can do with that. We cannot combine those because they are not like terms, simply because this is just the number 12, but this is 36 times some value x. We don't know what that value x is, so we cannot combine them. Please make sure you don't make that mistake. That's one of the number one mistakes that people make, and it's a common mistake, but you definitely don't want to make that mistake. All right, example number 3. Example 3, I'm going to use subtraction in this one. So we have multiplication and subtraction. So we're still distributing the 5 to everything in both terms in parentheses. Okay, and we can have several terms, however many terms in parentheses to distribute to. So 5 times 3m, and then I can say minus 5 times 6. 5 times 3m is 15m. 5 times 6 is 30. We cannot combine those. They are not like terms. Okay, now let's keep going. And these examples are pretty short. I just want you to see how to do this. This is very, very important, because if you know how to use the distributive property effectively, then you can go on and do some other things with expressions. All right, so one of the things I want to show you is that you can actually put the number that's being distributed on the right side as well. Okay, so even if I have this, this is still multiplication I have because it's in parentheses times 2. So I can work this backwards. It's still same thing. And I wouldn't even say backwards. I'm still distributing that 2 or whatever. So I can write this as 7 times 2 minus 6p times 2. Same thing, okay? That gives me 14 minus 6 times 2 is 12. 12p. Alright? And there's other ways we can write this. Remember, multiplication is commutative. So I could have said 2 times 7 minus 2 times 6p. But I want it to look like the setup up here. Okay? So we still are using the distributive property. Let's do 2 more examples. Now, you will see sometimes a fraction outside of the parentheses. Okay? Sometimes you can see a fraction being distributed. And if a fraction is being distributed, let's say we have 3/5 times the quantity 20t plus 5. Alright, so we're still distributing a fraction now. Boom and boom. So I have 3/5 times 20t plus 3/5 times 5. Let's make it happen. Now, several ways to multiply this fraction. How you choose to multiply it is up to you. I'm going to show you 2 ways. I can say 3/5 times 20t over 1 by just making this 20t a fraction. Remember, we can make any number, any whole number a fraction by simply placing it over 1. Okay? And then plus 3/5 will make this 5 a fraction as well. Okay? When I do that, 3 times, remember, fractions when we're multiplying fractions, numerator times numerator. So 3 times 20 is 60t. 5 times 1 is 5. Alright? Plus 3 times 5 is 15. 5 times 1 is 5. And then we can simplify that. So I'm going to write it over here. So 60 divided by 5 is 12t, and then 15 divided by 5 is 3, or tree. So that's important. But now we can also do this. Okay? So this is my solution, but I'm going to show you another way we can do it. Sometimes some people say 20t divided by 5. Okay? So 20 divided by 5 is 4. And they get that 4t times 3, which is 12t. So we can basically say 20 divided by 5 is 4t times 3. And then plus 5 divided by 5 is 1. And 3 times 1. So plus 3 times 1. Okay? And I still get 12t plus 3. All I did was actually take this whole number because I know this is a whole number. And this is in the denominator, so 20 divided by 5 is 4t. Well, if I keep the t, and then multiply it by this numerator. So take this divided by that denominator and multiply it by that numerator is where we get 3 times 1. But we still get the same answer, okay? Either way works. That's one of the beauties of mathematics. Let's look at one last example. All right, one last example. And as we do this one, I want to use a fraction again. And remember, the fractions can be on either side as well. This is example number 6. 1/2 12 minus 8f. So I have half of 12 minus half of 8f. Alright, so we can either way. In this case, I want to just think of it in terms of half of 12 is what? 6. And then half of 8 is 4. Keep the f. Okay? 6 minus 4f. We cannot combine those together. Now you can go ahead and multiply 1/2 times 12 over 1 minus 1/2 times 8f over 1, and it will still give you the same thing. So I'll show that way. Alright, so this gives me 12. 1 times 12 is 12. 2 times 1 is 2. Minus 1 times 8f is 8f. 2 times 1 is 2. Okay? So then from there, 12 divided by 2 is 6. 8 divided by 2 is 4. So, same answer. Okay? Just two different methods. So, hopefully this helps. Distributive property. Once again, thank you so much for watching. Follow me on Facebook, Instagram as well. The information is in the notes under this video. Thank you so much for watching. Please like, share, subscribe, and I'll be continuing to drop these videos for you. Once again, Young Gurus Math Tutoring. I got the solution to your math problems.